Bruh. 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 Dude, why are the AMC 12B and the usable so hard? God dang it. Bruh. What's kind of sad though is that even though the AMC 12B was harder, I did do better on the AMC 12B than the 12A. I did not take the 10A. 12A. But because I trolled very hard on the 12A, I just want to try it out with you guys, and I'll just walk you guys through my solution for the one that I did get right, and hopefully I can catch my mistake for the other ones too. So let us get started. Hello everybody, I'm Karar, and today we're just going to be walking through as many 2021 AMC 12A problems as we can. It'll be very epic. Okay, so I mean, I don't like really remember the answers, but like I obviously remember how I did it. So let's just get into it. Okay, so 2 to the 6 minus like 2 plus 4 plus 8. 64 minus like 14 is 50. Wow, very cool. 1B. And yeah, I think is that right? Yeah, that's probably right. Indeed. Actually, you know what? I should just open up the answer key in a different tab. Okay. And then for the next one, basically you just square both sides, right? And you get like a squared plus b squared is equal to a squared plus 2ab plus b squared, right? And essentially this simplifies to 2ab equals 0, so that means like ab just has to be 0. But like the one thing that I think people might have missed, right, is that a square root always has to be positive, right? Like if you take square root of 4, the answer is 2, okay? It's not plus or minus 2. Plus or minus 2 is only if you're like it's only if you're if you're solving an equation, right? If you're taking x squared is equal to 4, then like x is equal to plus or minus 2. But square root of 4 is like defined to be positive 2. Okay, so that is why it is just d, right? Like if the square root, the right side also has to be positive, so then it has to be. Alright, the sum of two natural numbers is 17,402. One of the two numbers is divisible by 10. Okay, if the unit digit of the number is erased. So essentially one is like a and one of them is 10a, right? Like 10a is 10a is the bigger number and a is a smaller number. So essentially it's just saying 9a is equal to we're trying to find 9a, right? And we're given that 11a is equal to 17,402, right? So essentially we just divide. Dude, this one took me so long to the actual thing. I don't know why, but like for some reason it took me so long to realize that this was a thing. I don't know, I did some random stuff with like digits and stuff. I don't even know what I did. Okay, so divide this by 11. 1, 6, 4, 5, 5, 5, 9, 0, 8, 1, 2. So A is equal to 1582, right? So essentially we just times 9 this, so 1582 times 9, 8, 1, 3, 7, 45, 4, or no, 5, and then 14, 14238, which is D, very cool. Alright, problem number 4. Tom has a collection of 13 snakes, 4 of which are purple and 5 of which are happy, okay? All of his happy snakes can add, right? So there's 5 happy dudes, right? And they can all add, okay? We know this for a fact. Okay, none of his purple snakes can subtract, and all of his snakes that can subtract also can't add, so that means none of his purple snakes can also add, right? Because all of them can't subtract, so all of them can't add, right? So essentially we know the purple snakes have to be a separate dude, because it's like 4 of these guys. And basically what can be drawn. So obviously the purple snakes can't add because they can't subtract. Purple snakes are happy. They are for sure not. They're like two separate things. Snakes that can add are purple. We know that only the people who can add are just the H's, or maybe like some of the non-H or purple guys. And then happy snakes are not purple. We know that, right? Because we found that like all the happy guys can add, but we know for a fact that the purple guys can't add, so should just be D. Very nice. And happy snakes can't subtract. We don't know that, okay? We cannot make any assumption about happy snakes. Maybe they're just too happy that they can't subtract. Who knows? Okay, so the answer is D. Very cool. Problem number 5. Okay, so multiply number 66 by the repeating decimal of that. So essentially you just get like 66 times 1 plus AB over 99, or we can just call it like X over 99. So X is equal to AB is equal to, and he also multiplies it just by 1 dot AB, right? Like not repeating. So essentially he can also multiply it by 66 times 1 plus x over 100, and he found that his answer, so he got this was 0.5 less than the correct answer, so this is like minus 1/2. So essentially we just solve for x, and we should get our answer, so we get 66, so that's just like 2/3 x, like minus 1/2, is equal to 33x over 50, right? So you subtract to this side, you get like 99 minus 100. Oh wait, what? Oh, sorry. You get like 100 over 9 or 150 x minus like 99 over 150 x is equal to 1/2, which gives you x is equal to 1 like the 1 over 150. So you multiply and you get x is equal to 75, which is E. Very cool. Alright, problem number 6. A deck of cards has only red and black cards. The probability of a randomly chosen card being red is 1/3. When 4 cards are added to the deck, the probability... Okay, so essentially, like, let's say the ratio, like, number red over total is equal to 1/3, right? Then if you add 4, so r over t plus 4 is equal to 1/4, right? So essentially, we just want to find t. So we get 3r is equal to t. Then you plug this in here, so you get like t over 3 over t plus 4 is equal to 1/4. Let us put this up there. Then you just get t plus 4 is equal to 4/3 t, which gives you that t is equal to, or 1/3 t is equal to 4, which t is equal to 12. And that is our answer, so C. Nice. Alright. Number 7. What is the least possible value of that? So essentially, if you just do it out, x squared y squared minus 2xy plus 1 plus x squared plus 2xy plus y squared, right? So, yeah, so what's cool is that this cancels out, right? And now essentially you have like 3 squared terms, or like all the terms with variables are squared, and then you have a plus 1, right? So you gotta know by the trivial inequality that like a squared number can't be less than 0, right? So essentially, like the smallest we can make all these squares is 0, right? If we just set x and y to 0, so then we get 0 squared to 0. You get the idea. So that just equals 1, and that has to be the smallest because these are all at least 0. So answer is D. Nice. All right, this one was fun, I think. I didn't like this one. Okay, I didn't like 10 even more, but 8 was kind of yucky too. So you basically have D0 equals 0, D1 equals 0, D2 equals 1. Okay, so basically you just have to write it out. So 0, 0, 1, and then n minus 1 and n minus 3. So it's basically every other. So this will be 1, this will be 1, this will be 2, this will be 3, this will be 4, this will be 6, this will be 9, and this will be 13, right? Yeah, and then this will be 19. So essentially, like, we have, what? We have even, odd, odd, even, odd, even, odd, odd. So, I mean, like, just looking at this, you could kind of assume that the pattern restarts here, but the way you know this, right, is that, like, once you have 3 that are the same as the original 3, right, when you have an EEO, then, like, the rest of the sequence is basically determined by the previous 3, right? Like, the only thing it depends on is n minus 1 and n minus 3, right? Those are only determined by the previous 3. So once we get this sequence of 3 again, we know that our whole sequence has to repeat. So essentially, every every 7 number that repeats, right? So this is like D0, 1, 2, 4, 5, 6, right? So essentially, the index mod 7 is where it like falls in this sequence, right? So 2021 divided by 7, let's see. 8, 5, 6, 6, 1, 5, 6, 5. So essentially, 2021 is going to be an even, right? Then 2022 is going to be odd, and then even again. So the answer is C. Very cool. Alright, nice. 9. Let's go to 9. Okay, this one was actually kind of fun. This one was great. I actually like this one a ton. So essentially, you just like multiply by 3 minus 2, right? So now then you get 2 plus 3. That becomes 3 squared minus 2 squared. Then you multiply that by 2 squared plus 3 squared. That becomes 3 to the 4 minus 4. 2 to the 4 is that big. And so on and so forth until you get 2 to the 64 minus 3 to the nope, nope. I'm getting too excited about this. 3 to the 64 minus 2 to the 64 times 3 to the 2 to the 61. I can't even talk anymore. 64 plus 2 to the 64, and that gives you 3 to the 128 minus 2 to the 128. Okay, and then that is your answer. Nice. And the reason why you can just multiply by 3 minus 2, is because it's equal to 1, right? So multiplying by 1 doesn't change anything, but it like gets you all this nice cancellation. Very cool. All right. Yeah, this one, I don't know. This is not even supposed to be that hard. Like, the answer is literally just 4 to 1. But, like, I spent so long trying to figure out, because I don't know. Wait, so is it, why is it so easy? I don't get it. Okay. So, essentially, we have, like, R is 3. We have H, right? Cone nonsense. 3, okay. And, essentially, we have another one where it's 6, right? H1, let's say. H2. Alright, so essentially all you get is, like, from volume, they're equal volume, right? So we essentially have 9 pi h1 is equal to like 36 pi h2. So essentially like h1 is just equal to 4 h2. Alright, So that is the main thing you gotta do. So what is the ratio of the rise of the liquid level? So essentially, like, you basically want it so that we have like this h prime 1, right? And we have h prime 2. And we want the volume of this new added area to be equal to the volume of the sphere. So essentially, these two volumes have to be equal because the sphere is the same. So I guess like the equation that I wrote first, and I didn't realize that it was kind of stupid, but the equation you had to write, right, is like this triangle here is similar to this triangle, right? The cones are similar. So whenever you have a ratio of a similar solid to another similar solid, the volume ratio is the cube of the side ratio. So essentially our side ratio is h1 prime plus like h1 over h1, right? That is our side ratio. So our ratio of the volumes is that cubed, right? So that is the overall cone, right? That is the um, ratio of the big cone to the small cone, and then you just subtract 1 to get this area, right? So essentially, then this is just times the volume of the big boy cone, or the volume of the cone, which should be the same for both of them. And then this has to equal v times like h2 prime plus h2 over h2 cubed minus 1. Okay. So, like, I don't know why I did not see this immediately, but if we like if we make this like what, we just make it, hold up. Oh yeah, like literally the ones cancel out, right? So like this one gets rid of that and the v's cancel out, right? So essentially we just have like h1 prime plus h1 over h1 cubed is equal to h2 prime plus h2 over h2 cubed, and we literally just take the cube root of this, and then you get h1 prime plus h1 over h1 is equal to h2 prime plus h2 over h2. This is just equal to 1, so that cancels out, and essentially you're left with h1 prime over h1 is equal to h2 prime over h2. And since we know that h1 is equal to 4h2, we can set this to 4h2, and we just get that h1 prime is equal to 4h2 prime. Very epic. Alright. Yeah, so I don't know why I didn't notice this. Yeah, I don't know why I didn't notice this in the actual thing. I did not realize that these things canceled out, so I was trying to solve a cubic nonsense. I tried to expand it and stuff. God dang, that was disgusting. I don't know why I did that. But it's okay, the answer is E. So we still got it. Very cool. Alright, this one was kind of cool, I'm not gonna lie. A laser is placed at the point 3, 5, right, somewhere there, and travels along a straight line, and you want it to hit the point 7, so that's like 4 over. That's not to scale. Although diagrams are never to scale in math. Alright, so 4. And essentially you want it to like hit here, go here, and go there. So essentially like, you know that this like angle theta, this is also angle theta, right? And you know like this is 90 minus theta, and then this is also 90 minus theta, and then this is 90 minus theta. So if this is 90 minus theta, and that is parallel to that, then this is also 90 minus theta. Which basically just tells you that like this thing is parallel to that, right? Like, I mean, obviously you could have noticed that, like, it's just a laser thing, right? If you ever look at how lasers work, you could see like if you like bounce it off of two perpendicular things, this thing is going to be parallel to that thing, right? So that's the first thing you got to notice, right? And then essentially, like, if we extend this, we want this to be 4, right? Actually, that seems pretty useless. What do we want to do? So essentially, we wanted to what? I forgot how I did this. It took me a bit of time to figure it out. I forgot what I did. Let's see. So this is 5, right? 5. Okay, so let's just say like this is like x, right? So this is 3. Okay, hold up. Let's redraw this diagram. Okay, so 3, 5, 7, 5. That's 4. Then essentially you want it to rebound off this wall, go here, and go like that. Okay. Oh, okay. So essentially, like, you know that this thing over here, is just like, since like this is just reflected over here, right? So, this distance over here has to equal this distance over there. But essentially, we also know that like this whole thing is 4, right? Because it's 4, there's a parallelogram that's 4, so this has to be 2, that has to be 2. So essentially, we know that if this is 2, so essentially it goes from 3, 5 to like -2, 0, right? So you basically get, right, this is going right 5 and up 5, so this is a 45-degree angle, right? So this is a 45-degree angle, and then it's easy, right? So then this is just 2 root 2, and then if this is 2, because of the 45, 45, 90 triangle, then this has to be 5 minus 2 is 3, right? So this is 3 root 2, and then this is just 5, right? So 5 root 2. So then you just do 3 root 2 plus 2 root 2 plus 5 root 2 is equal to 10 root 2, which is C. Epic. Alright, problem number 12. Alright, all the roots of the polynomial that are positive integers, possibly repeated, what is the value of... Okay, so essentially you know like the product of the roots, right? P, Q, R, S, or wait, what? Possibly repeated. Okay, well you basically know the sum of the roots is like 10, sum is 10, and then negative, positive, negative, positive, negative, positive, so product is 16. Well, okay, basically, like as soon as you see 16, like your options are pretty limited, right? So you need it to be integers, and you need the sum to be 10, positive integers too. So essentially, like you could basically just guess and check. That's how I did it. Like it has to be like 2 2, and then wait no what 2 2 yeah 2 2 2 1 1 are the roots, right? That's the only way to get like a product of 16 and a sum of 10. So then like B is just the like three-way product, right? So it'll be like PQR plus like PQS plus PQT, so on and so forth, right? So that's just going to be like you choose three of these. So the best way to do it is you know that like your three that you choose could either have three twos, two twos and a one, or one two and two ones, right? You can't have all three ones. So how many ways are there to get three twos? That's like four twos three, and if you do three twos, then your product is 8. And then if you want to do two twos and one one, then you do four twos 2 times 2, and then your product is 4. And then if you do 1 2 and 2 1s, there's only one way to choose the 1. There's 4 choose 1 ways to do the 2s, and then that will give you times 2. And is that it? Yeah, so then you just do this out. So 32 plus 6 times 8, 48, plus 8, which is equal to 88. Oh yeah, and then like by Vieta, there should be negative of that. So negative 88, very cool. Alright, of the following complex numbers, which of the one has the property that v to the 5 has the greatest real part? Okay. So I mean, basically you just convert this to polar, right? Like, I mean, there's no really smart way to do it, right? So 2 e to the pi I, and if you put this to the fifth, this just gives you 2 e to the 5 pi I, which is essentially equal to 2 e to the pi I. So your real part is negative 2. Alright. Then for the next one, it is like e to the negative root 3, 1. So that's like e to the 5 pi over 6 I, or 2. Well, okay, the magnitude doesn't really matter because they're all just magnitude 2, so we can just ignore that. So we'll just say like negative 1. We'll just make everything 1. Okay, so if you multiply this by 5, you get like e to the 25 pi over 6 I. So if you divide it, that's just equal to like e to the pi over 6, which is equal to like root 3 over 2. Okay, then the next one will be e to the 3 pi over 4. And if you do 5, that is equal to e to the 15 pi I over 4. And that is just what? That's like minus 8. So it's e to the 7 pi over 4, which is like if you go woo, 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 right? Like that? Yeah, okay, very nice. So then your real part is going to be equal to root 2 over 2. And if we do the next one, negative 1 root 3, that's e to the 2 pi over 3. Then you get e to the like 10 pi over 3 is what? That is minus 6, 4 pi over 3, right? 4 pi over 3 is, you go once and then you go down. So that is not going to work. So that's like negative 1/2, right? And then we got 2i. So that just has 0, right? So of these, this one has the biggest one, root 3 over 2, which is b. Epic. Alright, the next one was pretty creative, I'm not gonna lie. I like this one, actually, quite a bit. So, we essentially have a sum of log 5 to the k, 3 to the k squared. So, the first step, obviously, is to take out the exponent, right? No, what? Okay, so, think about it this way, right? So, if you take, like, log of xy, right? This essentially is equal to b. You're essentially saying x to the b is equal to y, right? Then, essentially, if you take a log of x to the c, y is equal to b, then you're saying x to the c, or no, we should say a different thing, is equal to c, or no, we already used that, a, that's kind of counterintuitive, but okay, x to the c to the a is equal to y, right? So essentially x to the ac is equal to y. So that basically means that ac is equal to b. So essentially that says that if we want to get from b to a, we had to multiply or divide by c. So if we write this as a formula, we essentially get that it's like log, or sorry, we get it's like c times log x to the c of y, right? So essentially in this case, we could divide, or sorry, what? Oh yeah, okay, yeah, so you divide by c. Okay, so essentially that means that this is 1 over k log 5 of 3 to the k squared. We take out the k squared from the log, and that basically gives you k log 5 of 3. And essentially, the only thing that changes when you're summing from 1 to 20 is the k. So essentially, you can factor out the log 5 of 3, and you get log 5 of 3, sum of k equals 1 up to 20 of k. So then we know this is just like n times n plus 1 over 2, so 20 times 21 over 2 is equal to 210. And then you multiply that by the other side, and we can literally just do the same thing. That's going to be sum from 1 to 100 of like log 9 of 25, which is just going to be 100 times that. So essentially you get like 210 times log 3 of 5, or 5 of 3, times 100 times log 9 of 25. And then does this cancel out? So if we swap bases, we're allowed to do that. When we multiply, we get 1/2 for log is equal to log 9 of 3, and 2 is equal to log 5 of 25. So that just cancels out, and we are left with 21,000, which is E, and that is correct. Alright, none of these were too bad. Oh, dude, this one's so stupid. Oh my god. Bro, I literally wrote on my paper, like, subtract 1 at the end. And I put 96, and the answer is 95. I literally wrote to subtract 1. Oh my god, I'm so triggered. God dang it. Okay, well, let's do it. Well, okay, now I like kind of know the smart way to do it. Like, I basically did casework on the number of tenors, right? Like I said, you could either have like, or I just did 0 through 1, 0 through 6 tenors, and I did the casework and summed it up, which was not hard, but it took a while. But the smart way to do it is, you just select, like, 6 tenors, 6 bases, right? And you just select, like, any subset of them, right? So you just take 2 to the 12, that's how many ways there are to take a subset of them, and then, like, you have 2 bases left over, right? So essentially, the difference between tenors and bases has to be something, right? And it has to be like within 2 of a multiple of 4. Yeah, so let's say you have like 6 tenors and like 3 bases, right? Then is there a way to fix this? Wait, is there? Maybe this is not a smart thing to do. But yeah, I don't think you could fix this one, right? Because then you'd have to lose 1. Yeah, I don't think this works actually. Huh. I thought that was a smart way to do it, because it is 2 to the 12 minus 1. What is, I don't know, what's the combinatorial argument for that though? I feel like that would be very cool. Yeah, okay, well why don't we just do the casework solution out, because that, I don't know a much smarter way to do it. Wait, there gotta be a smarter way, right? Okay, so why don't we just see if there's a pattern we can find with the, so we gotta do like 620 times like 8 choose, what? 8 choose 0 plus like 8 choose 4 plus 8 choose 8, and then 6 choose 1 times like 8 choose 2 times, sorry, 8 choose 3, or sorry, 8 choose 5. 8 choose 1 plus 8 choose 5, and then 6 choose 2. Well, I guess this is also applicable to 6 choose 5, right? And then the other one is like, if you choose 2 or 6, then we could do 8 choose 2 or 8 choose 6. And then the other one is if you do 6 choose 3 or 6 choose 7, but you can't do 6 choose 7, so that would be 8 choose 3 plus 8 choose 6, or 8 choose 7. And then this case also has like 6 choose 4. Okay, so if we just do out this multiplication, we should be fine, but that is kind of nasty. Actually not that bad, right? So essentially this is going to be like 1 plus 15, right? This is going to be 6 plus 6. This is going to be 1 plus 15. This is going to be 20 plus, or 20 times, okay. Wait, I swear there gotta be a nice way to do this, but okay, let's do it out and get the answer. Okay, 1 plus 1 plus 8 choose 4, so that's like 8 times 7 times 6 times 5, or 4 times 3 times 2. Okay, that gets out of here, that gets out of there, and we're left with 70, so that's 72. Then this is 8 times 7 times 6 over 6, so it's 56. So this is 28, this is 28, and this is 8 and 56. Okay, dang, I don't have enough space for this. So 16 times 72 plus 12 times 64 plus 20 times 64 plus 16 times 56. And we remember we had to subtract by 1 because 620 and 820 don't work together, so we had to subtract 1. This time we're not going to forget. Okay, so this will just be 720 plus 432, so that's just 1152. Then we have 640 plus 128 is 768, right? And then this, oh, we can combine these two. So 32 times 64, which is 2 to the 11. So that's plus 2048. Oh, we can combine these two as well. What the heck am I doing? Okay. So we combine these two, right? And then that gives you 72 plus 56 is 16 times 144, right? Or sorry, 128. So 16 times 128 is also 2 to 11. So that's 2048 minus 1. So that is equal to 4095. Okay. So that's basically how I did on the test. I forgot the minus 1, but that is how I did on the test. There gotta be a nice way to do it. I swear there's a nice way to do this. Okay, yeah. So basically, you do casework on the difference, right? So if you have no difference, right, then it's just like 6 choose 0 times 8 choose 0 plus like 6 choose 2 times 8 choose 2, so on and so forth, right? And that is essentially, what? That's basically like 6 choose like 0 times 8 choose 8 plus 6 choose 2 times 8 choose 6, right? And just going opposite directions. So it's like choosing how many people are not in the group, right? Which is essentially just equivalent of choosing like 14 choose like 8, right? Or 14 choose 8 where it has to be even, or huh? Oh, like not exactly Vandermonts because it has to be an even number, right? Oh wait, it doesn't have to be an even. I'm trolling. Okay, yeah. So it is 14 choose 8, right? And then if you only choose, if the difference is 2, right? So if you do 2, then it's like 6 choose 2 times 8 choose 0. Or sorry, 4. So 6 choose 0, or 6 choose 4 times 8 choose 0 plus like 6 choose 5 times 8 choose 0, so on and so forth. 8 choose 1. So like 6 choose 4 times 8 choose what? 7? 8 choose 8. Okay, so you're basically just choosing 12 from each thing. Yeah, so that's like plus 14 choose 12. And then I guess the other one is if it's flipped, then you get like 8 choose 0, or 6 choose 0, 8 choose 4, then 6 choose 1, 8 choose 5. So I guess that goes from like 8 choose 6 choose 0, 8 choose 4. So that's like plus 14 choose 4. And then if you have like 8 or negative 8, plus or minus 8, then it's either like, if it's positive 8, then it's like 6 choose 0, 8 choose 8, and that's it, right? So that's just like 14 choose 0, and then the other one is like 6 choose 8, which is not even an option. So essentially it's like this, whatever this is. So that's just like 14 choose 0 plus 14 choose 10, 14 choose 2 plus 14 choose 4 plus 14 choose 6, which is basically half of the sum of the even things in the row, which is just equal to 1/2 of 1/2 of 2 to the 14th. Oh, and then you subtract 1. Very nice. That is very epic. Okay. Okay, that is another option, I suppose. But I think casework is just the fastest one on the actual test, so I don't know. Okay, in the following list of numbers, the integer n appears n times on the list for 1 is less than or equal to n is less than or equal to 200. What is the median of the numbers in this list? Okay. So, essentially, let's figure out the numbers, the number of numbers in the list, which is just 200 times 201 over 2, right? So that's 20100. So essentially we want to find the like 10050th number. So essentially this is equal to like n times n plus 1 over 2, and we could approximately square like 100, so it should be around 100, right? Oh wait, is it right? I think I'm trolling. Hold up. No, that's right. So it's like, yeah, so n times n plus 1 is equal to that. So essentially we want like 100 squared. So like, we want like, what? Well, yeah, so we essentially want some number to equal like 201. So our number is going to be like around 140, right? So let's try 140 times 141. So let's see, 141 times 140. So that is going to be like 04615, okay? 01041, 04791. Okay, so you get 19740. And if you go up 1, I'm assuming if you do 141 times 142, you go over that. So you get 282,04650, 00141, and you get 221,010. Oh, so 20022. Okay, so that's fine. So I guess the next one you go over. Okay, so yeah, so essentially 141 gets repeated 141 times, and at the end there's been 20022 over 2 numbers. So essentially, when we're trying to find the 10050th number, the next number is going to be that. So it's just going to be 142, which is C. Epic. Alrighty, number 17, trapezoid ABCD has AB parallel to CD, right? And BC is equal to CD, and ADO, okay, so I need to be a bit careful. So AD, BD, or what? Oh. I see, alright. ADB, and then BC is equal to CD. So this is a isosceles triangle. I remember this was a pretty nasty problem. Hold up. Okay, so AC intersects here at O, and PB the midpoint of BD. So that's, and then this is 11, and we're trying to find this length over here. Okay, so first off, like this is a perpendicular bisector, the isosceles triangle, right? 43, 43. And then essentially this triangle is similar to this triangle. It's similar to that triangle, is it? I don't know if that's true. Okay, yeah. Well, at least this triangle is similar to that triangle. What else do we know? Oh, wait, it's also similar to this triangle. Oh, huh. So if we say this is x, right? Then we essentially know that, well, what? Can we just call this like h or something? Okay, well, then this is like xh over 11 by similar triangles. Okay, wait, they're not even similar. Hold up now. Let's draw this better. Okay, we have A, D, B. And then we have this. I forgot how I solved this one. So that is a perpendicular bisector, and we want to find from the intersection what this length is here. Or sorry, wait, what? That's 11, and we want to find this length. Okay, these are 43. Oh, these are it's a trapezoid. Okay, so this is parallel to that, and this is equal to that. And we know that this is equal to that because they're similar triangles. Okay, so this triangle is similar to which triangle? Nothing. Well, okay, this is similar to that. Yeah, let's just say this whole thing is x, right? This is x minus 11. So x plus 11 over x minus 11 is equal to this to that. Oh, so we have two ratios, right? So, x minus 11, or x plus 11 over x minus 11 is equal to this, right? And that is also equal to um, x minus 11 to 11. Oh, wait, this is big brain. Okay, so now I think if we solve this, we will get this length, and then it should be possible to get that length. Okay, so if we get like 11x plus 121 is equal to x squared, minus 21? Wait, sorry, minus 22. X plus 121, that gives you x squared minus 33. Okay, so that's just equal to, so x is equal to 33. Okay, hold on, let me undo that. Okay, so this boy right here is 33, then what is this guy? So we do 43 squared minus 33 squared. It gives you like 76. 76 times 10, right, is that. So that's root 76 times 10. And then this is just like 2211, so that's times 2. 2 of that. So root, what is this? 76 is divided by 4, right? So divide by 2, you get 38. So it's 19, 2 root 19, or 2 root 190. And then multiply by 2 is 4 root 190. So then you get D. Epic. Alright, so number 18, let a function be defined on a set of positive rational numbers with a property such that f of a times b is equal to f of a plus f of b for all positive rational numbers. So f of p is equal to p for every prime number. Okay, so essentially the idea is like, this one's kind of straightforward once you see the thing, but essentially if you have a prime factorization of a number like p to the r times like q to the r times s to the r, right? This is essentially equal to like f of p to the r minus 1 times f of, p to the r minus 1, q to, this should be like r1, r2, r3, r1, r2, r3, plus p, right? Because it'll be, you took out an f of p, so it'll be plus f of p, and then that's just equal to p, right? So essentially it's just equal to p plus p plus p plus p, dot dot dot. So you can take it out, r minus 1 times, r1 minus 1 times, and then same for q, right? So just the sum of all the prime factors. So essentially, if we just apply that here, 17, the only prime factor is itself, so it's just going to be 17. So for reciprocal, that is another question. So how do we get it for fractions? Then essentially, you basically could set like f of a over b plus f of b is equal to f of a, right? So essentially, f of a over b is equal to f of a minus f of b. So now if we apply this, right? So essentially, like the top, we want less than 0, right? So our top is going to be 17, and then we subtract 2 times 2 plus, or 2 plus 2 plus 2, as many number of 2s as there are in the prime factorization of 32, which is 5. So you just do 7 minus 10 is equal to 7. Okay. Then for the next one, it's 11 minus 8 is equal to 3. The next one is 7 minus 6 is equal to 1. Next one is 7 minus 5 is equal to 2. And the last one is going to be 10 minus 11 is equal to negative 1. So it is E. Epic. Bro, so many people silly number 19. I am one of them. I put like 3, but the answer is 2. So essentially the way you would do this is like sine is equal to cosine whenever like the angles are 90 minus each other, right? So let's just say for 0 to pi minus 2, right? Pi over 2, sorry. Then essentially we want pi over 2 cosine x to equal pi over 2 minus pi over 2 sine x, right? So in this case, you just have cosine x is equal to 1 minus sine x, and this is just true at, what? This is equal to 0 and pi over 2, right? So 0 and pi over 2 are for sure solutions. So now we have to look in pi over 2 to pi, right? So pi over 2 cosine x, so this is like, okay, so sine is going to be positive and cosine is going to be negative, right? So this is going to be negative, the negative. How do you get a negative number from this? Or is it going to be negative? Well, yeah, so this is guaranteed negative. This is guaranteed positive, right? There's no way this could be negative. So yeah, I guess there's no solution. I don't know how I found a solution there. I thought pi worked too, but it doesn't. Oh yeah. I guess I just like plugged it in here and I was like, oh, that works, but it doesn't. So these are the only two options. Okay. Dude, 20 I got so memed. Holy moly, dude. I knew the definition of a parabola going in, right? So it's essentially a directrix, a focus, and like every point on the parabola is equidistant from the focus and the directrix. But I drew it like this. What am I doing? God dang. Oh. So I kept like, okay. So I kept getting like this distance and this distance is equal to a or something, and then I wrote my equations wrong. But the actual graph how you're supposed to draw it is like that, obviously, right? Because this distance is equal to that distance. Let's say a. Bruh. I actually triggered. God dang it. Okay, so why don't we just call like this whole thing like a, right? Because we want the sum of the possible values of f to so this is f to v, so this is v, so we want this to be a, okay. And essentially we want a point on it such that AF, right, is equal to 20, which means that the distance to the directrix is also 20, and we want AV to be 21. Okay, so essentially we could like Pythagorean theorem this boy. Okay, so essentially like this is A, so essentially it is also A. So essentially 20 minus 2A squared plus like x squared, let's say, x squared is equal to 20 squared, right? Wait, that doesn't make sense. Or it does. Okay. And then 20 minus a squared is equal, or plus x squared is equal to 21 squared, right? And if we subtract the two, then what do we get? We basically get 3a squared. Wait, what? Negative 3a squared? Seriously? Okay, yeah. Negative 3a squared. So this is minus 40, that's minus 80, so that will be plus 40a. I mean, literally we're done here, right? Because then this just becomes like minus 41, right? So yeah, minus 41 is equal to 0. And then the sum of the roots is just b, negative b over a, which is 40 over 3. Nice. Oh, wait, sum? Yeah, sum is 40 over 3. Alright, nice. This one, I did not even get a chance to read these ones. So I don't know if I know how to do them, so why don't we try them together. Alright, so z minus 1 times z squared plus 2z plus 4. I'll probably only do 1 or 2 of these because I am somewhat close on time, but we'll see. Okay, so obviously this one has a solution to 1, right? Then the solution in the next one is like, what? Negative 2 plus or minus root 4 minus 4 times 4, which is like root 12i. Over 2. Oh, so that is like negative 1 plus or minus root 3 I. Okay. Then the next one is negative 4 plus or minus root 16 minus 24, which is negative 8i. So it's like minus 2 root 2i over 2. So that's just like, what? Wait, what? That doesn't seem right. Hold up. I think I guess that is right. I don't know. Yeah, that should be right. So this is like negative 2 plus or minus root 2i. I forgot what eccentricity is. Oh, so c is, okay, distance between foci over length of major axis. Okay. Okay, so essentially you have like A, C, and B. So how do you, let's see. Okay, so you have something at 1, then you have negative 2, wait. Oh, sorry, you have negative 1 plus or minus root 3, right? So you have, okay, so you have this, you have negative 1 plus or minus root 3, which is slightly greater than 1. And then you have negative 2 plus or minus root 2, which is also slightly greater than 1. And you want to find the eccentricity, right? Okay, so essentially you could write it as like x minus like a squared plus over a squared, let's say. Yeah, because I'm assuming, well, I don't know if it is that way, but we'll see. Y minus, well, not a squared, it should be just like some other thing. Let's say x minus x0 or something. Y minus y0 squared over b squared is equal to 1. 1? Yeah, okay. That is the standard form for an ellipse. So if 1, 0 is on this, right, then we essentially have, do we just have to plug everything in? No, I don't want to plug that in. That's going to be nasty. Hold up. Well, okay, we know that like y0 is 0, right? Like no matter what. Oh, so it's not even that nasty to plug in. So essentially we get like, if we plug 1, 0 in here, we get like 1 minus x0 squared over a squared is equal to 1, right? And if we plug negative 1 plus or minus root 3, then we get like 3 over b squared equals 1 plus 1 minus x0 over a squared squared. Oh, and then we can subtract these, and we basically get like, what? Wait, we subtract them, then that, wait, what, seriously? Oh, negative 1. Okay, negative 1. Alright, so if we subtract this, then we get something. Okay, well, let's just write out the equation. And then if we plug in negative 2 plus or minus 2, then you get like negative 2 minus x0 over a squared squared plus root 2, so 2 over b squared equals 1. Alright, so now we gotta somehow solve this. Okay, well, we could find like x over a in terms of this. So if we subtract them, we basically get negative, or sorry, you get, okay, so which one are we subtracting? Okay, let's subtract this one from this one. So if we square it, we get positive 2x. So we can essentially get like 2x0 over a squared plus 3 over b squared is equal to 0, which is pretty useful, right? Because if we plug in back into this equation, we get like what? Oh, I guess we just get that equation back. Oh, I see. It should be 4x0. 4x0 over a squared is equal to negative 3 over b squared. Alright, then what else could we do? Okay, well, basically we got like negative 3/4 a squared over b squared is equal to x0. Okay, why don't we try subtracting these two, right? Then essentially you get, what? You get like, this is 8x, or no, what? 4x0, 2x0, so you get 2x0, and then 3 plus 2x0 over a squared plus or minus 1 over b squared equals 2, 1, and essentially x is equal to like, let's clean this up, x is equal to negative 3/4, so then you get like 3 over a squared minus 3 over 2 b squared minus 1 over b squared is equal to 1. So essentially 3, oh, is equal to 0. Oh, nice. So essentially we get 3 over a squared minus 3 over, or minus 5 halves b squared is equal to 0, which basically means that b squared is equal to 5/6 a squared. Hey, nice. Okay, so we're getting somewhere. We're getting somewhere. Okay, so then c squared is just equal to like a squared minus b squared. So then that is like 1 minus 25 over 36, which is 9 over 36, which is what, 3 over 6? Oh no, 11 over 6. So root 11 over 6 is A is C. C over A. So root 11 over 6. So root 11 over 36. Now hold up. Oh, this is root 5. Oh, okay. So this is 1/6. So C is equal to 1/6 A squared. So C is equal to root 1 over 6. So 7, right? Is 7 the right answer? Hey, very nice. Okay, we solved number 21. I'm proud of that. Okay. Honestly, on the actual thing, I would never have time to solve it, but we did it, okay? I'm very proud of us. Let's go. Alright, this video is getting kind of long. I got through 1 through 21. I'll get through the rest of them soon. Let me know which one do you guys want to get see done. I might even do some of the AMC 10 ones in the next video, but let me know what you guys want to see. Alright, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Once again, let me know what you guys want in the comments, but other than that, I am done for today. So, thank you guys for watching again, and see you guys next time.